What is a speaker? This is a speaker. This is also a speaker. Now, which one has an electromagnetic coil that changes polarities multiple times a second? You guessed it, this one. Now let's take a closer look. This Bose-built speaker cube has 6 detachable and reattachable sides held together firmly with clips and friction. The semi-transparent frame allows for the RGB color changing module on the electrical component board to shine through brightly. The rear interface includes a power port, auxiliary input and output, and power and Bluetooth control buttons, as well as other expandable ports. A color phasing option is available with the sliding dial, as well as solid and variant options. As we all know, speakers produce sounds and music at high volumes that we are able to hear. But how exactly do speakers perform this apparently simple task? Well, there's quite a bit inside these boxes of music. Each speaker contains 3 main components that allow the speaker to function: a magnet, an electromagnetic coil, and the cone. This is the exposed part of many speakers that you are able to actually see. It's the one responsible for the actual sound produced by the speaker, and the one that you are able to see moving when you push the volume all the way up. This movement is caused by the electromagnetic coil. This coil is actually attached to the cone and reacts with the magnet inside the speaker to create this movement. The way that the cone is able to create sound is through this rapid movement. As the cone moves up and down repeatedly, the air surrounding the top of the cone moves. This movement creates a form of air compression called longitudinal waves. These longitudinal waves are a form of sound waves that can travel long distances. These waves make their way to the ear, and our ear is able to pick this up and comprehend it. This, in turn, creates sound and other noises, and depending on what you're playing through these speakers, music or voices. The cone shape and the figure of the cone contributes to the speaker's ability to better produce sound waves. Let's take a closer look inside a speaker. As I mentioned earlier, the electromagnetic coil is attached to the cone. This electromagnet also reacts with another key component of the speaker, the magnet, also referred to as the permanent magnet. This magnet is permanent because its polarity is fixed and does not change as an electromagnetic's polarity does, but more about this later. The magnet is usually attached to the base of the speaker's module within the frame of the speaker, as it is here. This magnet is usually within the wraps of the electromagnetic coil, but in this case it is surrounding the coil, which works in a similar manner. The electromagnet interacts with the magnet with either repelling or attracting magnetic fields. You see, an electromagnet is able to generate a magnetic field when an alternating current passes through it. Depending on the direction of the current, the magnetic field's polarity will switch. A clockwise and forward-moving current will produce a magnetic field with a north polarity at the top of the electromagnetic coil, and a south polarity at the bottom. However, a current moving in a reverse direction, counterclockwise, will cause the north pole to be at the bottom of the coil and the south pole to be at the top. The change causes the electromagnetic coil to become either attracted to or repelled to the permanent magnet. This change usually happens multiple times a second, and as a result, causes the coil and the cone to vibrate up and down rapidly. You are actually able to determine the polarity of the coil based solely on knowing the direction of the current that is flowing through the coil using your right hand. Making a thumbs up gesture, you take note of the direction that your fingers curl in. Since they move in a clockwise direction, the north pole is above the coil. Now for a current measure. As you can see, the multimeter is set to measure alternating current, which is a type of current that is traveling through the electromagnetic coil. When the current is measured, we can see that the voltage varies. My hypothesis on this is that the different pitch and tones of the song being played through the speaker create a different alternating current. This seems to be reflected in the changing voltage of the current that is displayed on the multimeter. And that's how a speaker works. Yes, it does.